Hi, hello, my dear students. A very good evening to all of you. Warm welcome to Turito live classes. So, we are discussing the chapter Polynomials. In the last class, we have discussed about remainder theorem. Okay. In today's class, we are going to discuss about the factor theorem. So, we are discussing factor theorem in today's class. So, once we can recap what we have discussed in the previous class. So, remainder theorem, and we have done some problems related to remainder theorem. So, what is the remainder theorem? So, for the given polynomial f of x, if x minus a is a factor, then the remainder is f of a. So, we need not to use the general method of division of polynomials for finding the remainder. So, just by using that method easily we can find the remainder for the given polynomial. So, in today's class, the learning objectives means in today's class we are going to discuss, we will learn following concepts in this topic: factor theorem, next factorization of polynomial, factor theorem, factorization of polynomial, and we can do some problems related to these concepts. So, first let us discuss what is the factor theorem. Okay. If we suppose that p of x is any polynomial of degree greater than or equal to 1 and a is any real number, then number 1, x minus a is a factor of p of x if p of a equal to 0. Next, p of a equal to 0 if x minus a is a factor of p of x. So, by observing these 2 points, so clearly second point is the converse of the first point. You may take any polynomial and you can name that polynomial as p of x. If p of x is any polynomial of degree greater than or equal to 1. If you take the degree of the polynomial exactly 1, clearly we can say that is linear polynomial. So, minimum you have to take the linear polynomial. So, more than 1 means 2, 3, 4, 5, 6, you may take any degree. So, then x minus a is a factor of p of x, p of a equal to 0. So, in the last class we have discussed about the remainder theorem. So, x minus a, if you take x minus a equal to 0, in the given polynomial in place of x, if we substitute a, then you will get the remainder. If that remainder is 0, then we can say x minus a is a factor. So, for example, if we divide 8 by 4, 4 2 ja 8, remainder is 0. So, in this case we can say 4 is the factor of 8. So, by dividing 8 by 4 exactly, we are getting the remainder as 0. That is why we can say 4 is the factor of 8. Similarly, if you divide 8 by 5, so 5 1 ja 5, 8 minus 5 3, in this case we are getting the remainder as 3. That is why in this case we can say 5 is not the factor of 8, 5 is not the factor of 8. Similarly, we can apply the same for the polynomials also. So, if we divide the polynomial by x minus a, if we get the remainder as 0, then we can say x minus a is a factor. Or if we take the converse part of this, if p of a equal to 0, in the given polynomial in place of x, by writing a, after simplification if we get 0, then we can say x minus a is a factor. Both are same. X minus a is a factor of p of x, then p of a equal to 0. If p of a equal to 0, then x equal to a is the solution, that is nothing but x minus a is a factor of p of x. So, let us take the small example. If we suppose that f of x equal to or p of x equal to x minus 1. So, clearly in place of x, if we write 1, f of 1 equal to 1 minus 1 equal to 0. So, in this case we can say here this 1 is the root or solution. root or solution of the polynomial x minus 1. Here also if x minus a is a factor of p of x, if p of a equal to 0, here in place of a I am taking 1. Similarly, if p of a equal to 0, here in this polynomial in place of x if you write 1, again you will get 1 minus 1 equal to 0, then we can say x minus 1 is a factor of the polynomial. So, let us consider an example. For the polynomial x square minus 5x plus 6, x minus 2 and x minus 3 are the factors. If you suppose that the given polynomial x square minus 5x plus 6 is p of x, or you may take f of x. You can take the polynomial as f of x, g of x, p of x, your wish. So, in this polynomial, so here we have taken x minus 2 and x minus 3. Actually, this is a quadratic polynomial. This is a quadratic polynomial. Already in the previous classes we have discussed. The degree of the polynomial represent the number of zeros of the polynomial. So, since this is a quadratic polynomial, the degree of that polynomial is 2, then this polynomial contains 2 zeros. They are 2 and 3. According to this example, we have taken x minus 2 and x minus 3 are the factors. If x minus 2 is a factor, means you can take x minus 2 equal to 0. So, you can take x equal to 2. So, by taking x equal to 2, what will you get? P of 2 equal to 2 square 4 minus 5 2 is 10 plus 6. Where 4 plus 6 10 minus 10 cancel, we got 0. So, P of a equal to 0, P of 2 equal to 0. Similarly, in place of x by writing 3, in place of x by writing 3, then you will get P of 3 equal to 3 square 9 minus 5 3 is 15 plus 6, where 6 plus 9 15 minus 15 get cancelled 0. In the polynomial x square minus 5x plus 6, by substituting x equal to 2 and x equal to 3, after simplification we have gotten the value is 0. That is why we can say x equal to 2 and x equal to 3 are the zeros of the polynomial x square minus 5x plus 6. If x minus 2, if x equal to 2 and x equal to 3 are zeros, means x minus 2 and x minus 3 are the factors of the polynomial x square minus 5x plus 6. Okay, very simple. So, only x equal to 2 and x equal to 3 satisfy the polynomial x square minus 5x plus 6, means in place of x by substituting 2 and 3 only, after simplification you will get 0. For the remaining values of x other than 2 and 3, if you take any value in place of x in the polynomial x square minus 5x plus 6, you should not get 0. That is why only 2 and 3 are the zeros. 2 and 3 are the zeros, means x minus 2 and x minus 3 are the factors. So, this is known as factor theorem. So, this factor theorem is very important, and we can use this concept or this formula in the remaining chapters also. So, what is the factor theorem? If we suppose that one polynomial is there, and if we suppose that that is p of x. If p of x is any polynomial of degree greater than or equal to 1 and a is any real number, then x minus a is a factor of p of x if p of a equal to 0. Conversely, if p of a equal to 0, if x minus a is a factor of p of x. So, for the polynomial x square minus 5x plus 6, we can take x minus 2 and x minus 3 are the factors. Similarly, if p of 2 equal to 0 and p of 3 equal to 0, then we can say x minus 2 and x minus 3 are the factors. X minus a is a factor of p of a equal to 0, means x equal to 2 and x equal to 3 are the zeros of the polynomial x square minus 5x plus 6. So, can you say what are the zeros or factors of the polynomial x square minus 1? Can you send your answer? So, I have given the polynomial f of x equal to x square minus 1, clearly that is a quadratic polynomial. So, since this is a quadratic polynomial, then this contains 2 zeros. So, if we substitute x equal to 1 you will get f of 1 equal to 1 square minus 1, that is 0. Similarly, in place of x, by writing minus 1, f of minus 1 equal to minus 1 square minus 1. Again minus 1 square is 1. So, minus 1 equal to 0. That is why x equal to 1, x equal to minus 1 are the zeros. Means x minus 1, here x plus 1 are the factors of x square minus 1. So, this is factor theorem. Now, we can do some problems related to the factor theorem. Now, here we have one point. Thus, if the sum of all coefficients of the terms in a polynomial is 0, then x minus 1 is a factor. So, this is shortcut. So, just you can take the given polynomial whatever the degree may be, whatever the degree may be. If the sum of all coefficients, if the sum of all coefficients of the terms in a polynomial is 0, then x minus 1 is a factor. So, for example, if we take x square minus 2x plus 1, if you suppose that the quadratic polynomial is x square minus 2x plus 1, where the coefficient of x square is 1, where the coefficient of x is minus 2, constant term is 1. By adding 1 plus minus 2 plus 1, 1 plus 1 2 to get cancelled, we got 0. That is why we can say x minus 1 is a factor. So, let us check whether that is correct or not. If you take x equal to 1 in this polynomial, 1 square 1 minus 2 1 are 2 plus 1, 1 plus 1 2 to get cancelled, we got 0. So, it is applicable for any polynomial, not only for quadratic polynomial. You may take cubic polynomial, you may take pi-quadratic polynomial, or you may take 6th degree polynomial. Whatever the degree of the polynomial may be, if the sum of all coefficients, so for example, if we take x power 4 minus 1, actually that is a 4th degree polynomial where x power 4 coefficient is 1, constant term is minus 1. By adding these two, you will get 1 minus 1 equal to 0. That is why we can say x minus 1 is a factor. So, if the sum of all coefficients of the given polynomial is 0, then you need not to check, directly you can take x minus 1 is a factor. X minus 1 is a factor means x equal to 1 is the 0 of the polynomial. Next, if the sum of coefficients of even powers of x is equal to sum of the coefficients of odd powers of x, then x plus 1 is a factor. Then x plus 1 is a factor. In the given polynomial, if the sum of coefficients of even powers of x means x square or x power 4 or x power 6 is equal to sum of the coefficients of odd powers of x, sum of the coefficients of odd powers of x, then x plus 1 is a factor. Then x plus 1 is a factor. You may take any degree polynomial, take the coefficients of x even powers of x and take the coefficients of odd powers of x, add them. If both are equal, then we can say x plus 1 is a factor. This is also a shortcut. So, actually in competitive exams, we have to do the given problems as fast as possible. So, sometimes we can do the calculation, simplification of the given problem by using some shortcuts. But remember that every problem may not have the shortcut. But if the shortcut is applicable for the given problem, it is better to apply that. So, if the sum of coefficients of even powers of x is equal to sum of the coefficients of odd powers of x, then x plus 1 is a factor. Okay. So, you can remember these 2 points. So, if the sum of all coefficients of the terms in a polynomial is 0, then x minus 1 is a factor. If the sum of coefficients of even powers of x is equal to sum of the coefficients of odd powers of x, then x plus 1 is a factor. X plus 1 is a factor. Okay. Now, factorization of polynomial. Factorization of polynomial. So, when a polynomial is given, how can we factorize? So, for example, if we have 8, this 8 can be written as 2 into 4, or you may write 1 into 8 or 4 into 2, 8 into 1. So, if we have 15, we can write 3 into 5 or 1 into 15 like that. So, here if we express 8 as 2 and 4, we can say 2 and 4 are the factors of 8. Similarly, 1 and 8 are the factors of 8. Similarly, if we express 15 as 3 into 5, then we can say 3 and 5 are the factors of 15. Or you may write 1 into 15, 1 and 15 are the factors. So, just like that, for a polynomial, let p of x and q of x be two polynomials. If q of x divides p of x exactly, then q of x is called the factor of p of x. Exactly means we have to get the remainder as 0. We have to get the remainder as 0. So, just I told you, if you divide the number 8 by 2, you will get 2 4 8, we have remainder 0. In this case, we can say 2 is the factor of 8. So, divides exactly means we have to get the remainder as 0. Similarly, if we divide 8 by 3, you will get 3 2 6, 8 minus 6, 2 is the remainder. So, we have not gotten the remainder as 0. That is why we can say 3 is not a factor. So, for the polynomials also, if we divide one polynomial by another polynomial, if we get the remainder as 0, then we can say the second polynomial should be the factor of the first polynomial. So, for example, if we take first polynomial is f of x equal to x square minus 1, and second polynomial is g of x equal to x plus 1 or x minus 1. Divide x square minus 1 by x plus 1. Here my question is, check whether x plus 1 is a factor or not of x square minus 1. Just you can apply factor theorem. Here we have x plus 1. That's why you can take x equal to minus 1 here. So, then what will you get? F of minus 1 equal to minus 1 square 1 minus 1 equal to 0. So, since in place of x by substituting minus 1 we got 0, then we can say x plus 1 is a factor of x square minus 1. For the same polynomial x square minus 1, check whether x plus 2 is a factor or not. So, to check whether x plus 2 is a factor or not for the polynomial x square minus 1, in place of x you can substitute minus 2. So, then what will you get? F of minus 2 equal to minus 2 whole square is 4 minus 1, that equal to 3. So, since the remainder is a non-zero number, then we can say x plus 2 is not a factor of the polynomial x square minus 1. So, by dividing one polynomial by another polynomial, if we get the remainder as 0, then we can say the second polynomial is dividing the first polynomial exactly. In this case, we can say the second polynomial is the factor of the first polynomial. So, let p of x and q of x be two polynomials. If q of x divides p of x, if q of x divides p of x, after simplifying, if we get the remainder as 0. So, if q of x divides p of x exactly means we have to get the remainder as 0. Then q of x is called the factor of p of x. Example, x minus 2 is a factor of x square minus 3x plus 2. X minus 2 is a factor of x square minus 3x plus 2. So, if you suppose that the polynomial is f of x equal to x square minus 3x plus 2. Here we have to check whether the remainder is 0 or not. You do not need to apply the general method of the division of polynomial. So, just we have to check whether the remainder is 0 or not when the first polynomial is dividing by the second polynomial. So, we are dividing x square minus 3x plus 2 by x minus 2. X minus 2 means if we take x minus 2 equal 0, x equal to 2, then f of 2 equal to 2 square 4 minus 3 2 6 plus 2, where 4 plus 2 6 minus 6 get cancelled 0. That is why we can say x minus 2 is a factor of x square minus 3x plus 2. Similarly, x plus 1 is a factor of x square minus 1. So, you can take f of x equal to x square minus 1. We are dividing this polynomial x square minus 1 by the linear polynomial x plus 1. X plus 1 means by taking x plus 1 equal to 0, you will get x equal to minus 1. In place of x, by writing minus 1, f of minus 1 equal to minus 1 square 1 minus 1 equal to 0. That is why we can say x plus 1 is a factor of x square minus 1. So, if by substituting x equal to in the polynomial x square minus 3x plus 2, if you not get the remainder as 0, then we can say that is not a polynomial. Let p of x and q of x be two polynomials. If q of x divides p of x exactly, then q of x is called the factor of p of x. So, we can conclude that by taking these two examples. So, hope you understood more. Next. So, factorization of polynomials. So, just write 8. So, we can write 2 into 4 or 1 into 8, 6 is there. We can write 2 into 3 or 3 into 2 like that. So, just like that we have to factorize the given polynomial. If we express the given polynomial as the product of two or more polynomials such that the degree of each factor is less than degree of the given polynomial. So, for example, if we have a quadratic polynomial, if we express that quadratic polynomial as the product of two polynomials, but here you have to remember, by expressing two or more polynomials, for each polynomial the degree should be less than the given polynomial. If you express the given polynomial as the product of two or more polynomials such that the degree of each factor is less than the degree of the given polynomial. Example, x square minus 16 can be written as x minus 4 into x plus 4. So, we have x square minus 16, x square minus 16 can be written as 4 square. So, we have the identity a square minus b square equal to a minus b into a plus b. So, we have the formula a square minus b square equal to a minus b into a plus b. So, already we have learned that formula in previous class. A square minus b square equal to a minus b into a plus b, where in place of a we have x, in place of b we have 4. So, the formula is a minus b x minus 4 into a plus b x plus 4. So, we have expressed the polynomial x square minus 16 as the product of two linear polynomials x minus 4 and x plus 4, x minus 4 and x plus 4. By observing x minus 4 is a linear polynomial because the degree is 1. X plus 4 is also a linear polynomial because the degree is 1. So, we have expressed the quadratic polynomial x square minus 16 as the product of two linear polynomials x minus 4 and x plus 4. Now, this x minus 4 is said to be the factor of x square minus 16. Similarly, x plus 4 is also the factor of the polynomial x square minus 16. Next, if we take x square minus 5x plus 6, x square minus 5x plus 6, clearly this is a quadratic polynomial. This is a quadratic polynomial. So, when a quadratic polynomial is given, then we know how to express that as the product of two linear polynomials. If you take RHS part, x minus 2 into x minus 3, if you take RHS x minus 2 into x minus 3, where x into x, x square, x into minus 3, minus 3x, minus 2 into x, minus 2x, minus 2 into minus 3, plus 6. So, x square minus 3x minus 2x is minus 5x plus 6. So, by multiplying the two linear polynomials x minus 2 and x minus 3, we have gotten x square minus 5x plus 6. So, that is why we can say x minus 2 and x minus 3. These two are the factors of the polynomial x square minus 5x plus 6. So this is known as factorization of the polynomial. We may have quadratic polynomial or cubic polynomial or biquadratic polynomial. Whatever the polynomial may be, if we express that polynomial as the product of two or more polynomials such that the degree of each polynomial should be less than the degree of the given polynomial, then we can say each expression is the factor of the given polynomial. So hope you understood. Next, here we have some note. A square minus b square equal to a minus b into a plus b. So already we have this identity in 8th standard. Similarly, you can remember a cube plus b cube equal to a plus b into a square minus ab plus b square. A into a square a cube, a into minus ab minus a square b, a into b square ab square plus b into a square b, b into minus ab minus ab square, b into b square b cube. By simplifying that, we will get a cube plus b cube. So for example, if you suppose that a cube plus b cube is a polynomial, a cube plus b cube is a polynomial, then we can express that polynomial as a plus b into a square minus ab plus b square. So this a plus b is one factor of a cube plus b cube. A square minus ab plus b square is also the factor of a cube plus b cube. Similarly, a cube minus b cube can be written as a minus b into a square plus ab plus b square. So you have to keep remembering these formulae because we can apply these formulae for solving the given problems. If the given polynomial is in the form of a square minus b square, so just we have applied that x square minus 16 by writing 16 as 4 square, x square minus 4 square a minus b into a plus b. So a square minus b square can be represented as a minus b into a plus b. Next, if we take a cube plus b cube, so we can express that as a plus b into a square minus ab plus b square. Next, if we take a cube minus b cube, a minus b into a square plus ab plus b square. So we have to keep remembering these formulae. Now let us do the problems related to the concepts which we have discussed so far. So problem number 1. Check whether g of x equal to x by 3 minus 1 by 4 is a factor or not for the polynomial f of x equal to 8x cube minus 6x square minus 4x plus 3. So here two polynomials are given. First polynomial is linear polynomial, second polynomial is cubic polynomial. We have to check whether the first polynomial is a factor or not for the second polynomial. According to the problem, we have f of x equal to 8x cube minus 6x square minus 4x plus 3. So we are dividing this by g of x. What is g of x? X by 3 minus 1 by 4. So let us consider x by 3 minus 1 by 4 equal to 0. By taking minus 1 by 4 to that side, you will get x by 3 equal to 1 by 4. So by cross multiplying, you will get 3 1 ja 3 by 4. So in place of x, let us substitute 3 by 4. In place of x, by substituting 3 by 4. Put x equal to 3 by 4 on both sides, then you will get the remainder. If that remainder is 0, then we can say that is a factor. If that is a non-zero number, we can say that is not a factor. So then what will you get? F of 3 by 4 equal to 8x cube, 8 into 3 by 4 whole cube minus 6x square minus 6 into 3 by 4 whole square minus 4x minus 4 into 3 by 4 plus 3. So that is 8 into, where 3 cube is 27, 4 cube is 64. 3 by 4 into 3 by 4 into 3 by 4 minus 6 into 3 square 9, 4 square 16 minus 4 get cancelled, we have minus 3 plus 3. So we can cancel minus 3 plus 3. Here 8 8 is 64. 8 8 is 64. We have 27 by 8. Here we can cancel 6 and 16 by 2. 2 3 times, 8 times, 3 9 is 27 by 8. So this is plus 27 by 8, this is minus 27 by 8, we got 0. So since the remainder is 0, then we can say x by 3 minus 1 by 4, that is nothing but g of x is a factor of f of x, means 8x cube minus 6x square minus 4x plus 3. So we can write the conclusion as therefore g of x means x by 3 minus 1 by 4 is a factor of f of x. What is f of x? 8x cube minus 6x square minus 4x plus 3. So whatever the problem may be, to check whether one polynomial is factor or not for the another polynomial, just you can take the small polynomial, means you can take the polynomial having the lowest degree. Here x by 3 minus 1 by 4 have the degree 1, that is linear polynomial. From that we got the value of x as 3 by 4. You can substitute this 3 by 4 in the given polynomial 8x cube minus 6x square minus 4x plus 3. After simplification we got 0. That's why we can say x by 3 minus 1 by 4 is the factor of 8x cube minus 6x square minus 4x plus 3. So hope you understood this. Next, show that 2x minus 3 is a factor of x plus 2x cube minus 9x square plus 12. So first of all, the given polynomial, means second polynomial is not in the standard form. If you want, you can convert that as a standard polynomial, otherwise you can keep as it is. So if you take, they have not given the name of the polynomial, so that's why I am taking f of x. You may take f of x or p of x. So f of x equal to, by writing in the order, 2x cube minus 9x square plus x plus 12. But it is not necessary to express the given polynomial as a standard polynomial. By keeping x plus 2x cube minus 9x square plus 12 as it is also, you will get the same answer. Now we are dividing this polynomial by 2x minus 3. So let us take 2x minus 3 equal to 0. By taking minus 3 to that side, you will get plus 3. By dividing on both sides by 2, you will get x equal to 3 by 2. X equal to 3 by 2. Now by substituting x equal to 3 by 2 in this polynomial, after simplification, if we get 0. So put x equal to 3 by 2. So put x equal to 3 by 2, then you will get f of 3 by 2 equal to 2 into x cube 3 by 2 whole cube minus 9x square minus 9 into 3 by 2 whole square plus x plus 3 by 2 plus 12. So that is 2 into 3 by 2 whole cube. 3 cube is 27, 2 cube is 8 minus 9 into 3 square 9, 2 square 4 plus 3 by 2 plus 12. Here we can cancel 8 by 2 4 times. So you will get 27 by 4 minus 9 9 ja 81 by 4 plus 3 by 2 plus 12. So by taking 4 as LCM, in numerator you will get 27 minus 81. If you divide 4 by 2, 2 times, 2 3 ja 6 plus 12 by 1. So by dividing 4 by 1, you will get the quotient for 4 12 ja 48 by 4. Here by adding the positive terms, so 27, 6 and 48 are the positive terms. 27 plus 6, 33. 33 plus 48, 8 plus 3, 11, 4 plus 3, 7 plus 1, 81. By adding positive terms, we got 81. Only one negative term is there, minus 81 by 4. 81, 81 get cancelled. So we got 0 by 4. 0 by 4 means 0. So in place of x, by substituting 3 by 2 in the polynomial 2x cube minus 9x square plus x plus 12, then you can write the conclusion. Therefore, 2x minus 3 is a factor of x plus 2x cube minus 9x square plus 12. So, you can write the conclusion like that. 2x minus 3 is a factor of x plus 2x cube minus 9x square plus 12. So, hope you understood. Here the problems are very easy, but calculation part is very, very important. Now, look at this. By using factor theorem, show that x power 4 plus 2x cube minus 2x square plus 2x minus 3 is exactly divisible by x plus 3, just like the previous problem. Here they have not given the name of the polynomial, that is why let us consider the first polynomial x power 4 plus 2x cube minus 2x square plus 2x minus 3 as some f of x. By taking f of x equal to x power 4 plus 2x cube minus 2x square plus 2x minus 3. Let us take the first polynomial as f of x, x power 4 plus 2x cube minus 2x square plus 2x minus 3. We are dividing this by the polynomial x plus 3. So, if we take x plus 3 equal to 0, from this we will get x equal to minus 3. They will get x equal to minus 3. So, in place of x on both sides, by substituting minus 3, put x equal to minus 3. Then what will you get? F of minus 3 equal to minus 3 power 4 plus 2 into minus 3 whole cube minus 2 into x square minus 3 whole square plus 2 into minus 3 minus 3. So, by simplifying, minus 3 power 4 minus 3 into minus 3 into minus 3 into minus 3. So, since the power is an even number, so minus 1 power 4 is even. So, you will get plus 3 power 4 is 81. So, plus 81 minus 2 into minus 3 cube minus 27, minus 27 into 2 minus 54 minus minus 3 whole square minus 3 into minus 3 plus 9, 9 into 2 is 18, 2 into minus 3 minus 6 minus 3. Here by adding the positive terms, we have only one positive term, that is 81. By adding the negative terms 54, 18, 6 and 3, these are the negative terms. 54 plus 18, 72 plus 6, 78 plus 3, 81. So, since all the terms are negative, we can take minus 81, 81, 81 get cancelled, we got 0. We got 0. So, that is why we can say for the polynomial x power 4 plus 2x cube minus 2x square plus 2x minus 3, x plus 3 is a factor. So, we have proved this by using factor theorem, means in place of x I have taken minus 3. After simplification we got 0. So, that is why we can say conclusion. Therefore, x power 4 plus 2x cube minus 2x square plus 2x minus 3 is exactly divisible by x plus 3. So, hope you understood my next problem. If x minus a is a factor of x cube minus a x square plus 2x plus a minus 1, then find the value of a. So, they have given x minus a is a factor of this polynomial x cube minus ax square plus 2x plus a minus 1. Let us take that polynomial is f of x. So, f of x equal to x cube minus ax square plus 2x minus plus a minus 1. So, what they have given, x minus a is a factor. Since x minus a is a factor, then we can take f of a equal to 0. In place of x, write a and you can substitute that, you will get the value of a. So, first of all, I am taking the given polynomial as some f of x. Let f of x equal to x cube minus ax square plus 2x plus a minus 1. Let us take x cube minus ax square plus 2x plus a minus 1, that is f of x. According to the problem, for this polynomial f of x, x minus a is a factor. x minus a is a factor means f of a equal to 0. Since x minus a is a factor, then f of a equal to 0 according to the factor theorem. X minus a is a factor means f of a equal to 0, or if f of a equal to 0, then x minus a is a factor. So f of a equal to 0 means here in this polynomial, in place of x, by writing a x cube minus a into x square, a square plus 2a plus a minus 1 equal to 0. So from this, a cube minus a into a square, a cube, 2a plus a, 3a minus 1 equal to 0. We can cancel a cube minus a cube. The remaining part is 3a minus 1 equal to 0. By taking 1 to that side, you will get 3a equal to 1. 3a equal to 1. So from this, by dividing on both sides by 3, you will get a equal to 1 by 3. According to the problem, we have to find the value of a when x minus a is a factor of the polynomial x cube minus ax square plus 2x plus a minus 1. So take this polynomial as f of x. Since x minus a is a factor, then you can take x equal to a. Is the 0 means f of a equal to 0. In place of x, by substituting a, and after simplification, we got the value of a is 1 by 3. So hope you understood this. Next, for what values of m, x cube minus 2m x square plus 16 is divisible by x plus 2. So in place of m, by substituting some values, then this polynomial should be divisible by x plus 2. So just like the previous problem, in the previous problem we have unknown value a, here we have m. So first let us take the polynomial x cube minus 2m x square plus 16 as some f of x. So by taking the polynomial as f of x equal to x cube minus 2m x square plus 16. So since we are dividing by x plus 2, so we can take x equal to minus 2. So we are dividing this by x plus 2. So in place of x, by writing minus 2. We are dividing by x plus 2 means we can say x equal to minus 2 is the 0, or x plus 2 is a factor. So put x equal to minus 2, then you will get p of minus 2, f of minus 2 equal to 0. So f of minus 2 equal to 0. Why? We are dividing this by the polynomial x plus 2. In place of x, by writing minus 2 cube minus 2m into minus 2 square plus 16 equal to 0. Minus 2 cube is minus 8 minus 2 whole square is 4. Minus 2 into minus 2 plus 4. 4 into 2, 8 minus 8m plus 16 equal to 0. So where minus 8 plus 16 is 8. 8 minus 8m equal to 0. By taking 8 to that side, that should be plus 8. So from this you will get, by dividing on both sides by 8, 8 by 8 equal to 1. So in place of m, by writing 1 means x cube minus 2x square plus 16, then that polynomial should be divisible by x plus 2. So x cube minus 2mx square plus 16 is given. In place of m, by substituting what values, that should be divisible by x plus 2. So take this polynomial as f of x. Since we are dividing by x plus 2, then f of minus 2 equal to 0. In place of x, substitute minus 2 and simplify. After simplification, we got m equal to 1. So according to the problem, we have to find the values of m only, that is 1. Okay. So these are some problems related to factor theorem and factorization of polynomials. In the next class, we can discuss some more concepts related to factorization of polynomials. So thank you all my dear friends for subscribing to Turito. Thank you very much. Have a nice day.